Okay. As it is, I am going to be soldering awfully close to some dial cordage and this dial itself. I think it's a good idea to put some precautions. This is just a piece of folded aluminum foil, 4 layers thick, is about right. If I bump into it, there's no way quickly that enough heat's going to get to do any harm. So I'm going to wrap this not only around the dial cords, but also around the drum. And I've been fiddling with it. And the best way I've seen to kind of work it up in there. A couple of components you might have to get past. You get it up in there, and then kind of work over towards the left, which in this case is where I need to get the components I need to get at are toward the left as viewed, and also one down here which is awfully close to these dial cords. Well, I can pull this whole mess up out of the way and sort of guard it this way. And some nylon wire ties. I didn't have long enough ones, so I just pieced a few together. I'll put one on each side, kind of sneak it up on in there, get it started. Another one over on this side. Get it started. Yeah, I'm up on something. What is? There we go. Just sort of draw them up tight. Not too tight. Get this out of the way. And we'll leave those in case I want to fiddle with that some more. But yeah, that gets it. The dial cords are safe. The drum here is safe when I get to soldering. Down in there and up in here, the same deal. If I twitch, I won't damage anything. I do twitch. You get old, you twitch. So we'll see how it goes. I'm going to replace these 4 first, and then give it a try. Just wanted to go through how I was going to secure that dial cord and dial drum, so I didn't screw it up. The other thing, I don't know if I've mentioned this already, and it's very important. This model radio and others, all of the transistors in it are PNP. Every single one of them. There's 12. They're all PNP. Because of that, the chassis is at what is normally known as B+, meaning it's a positive ground. It's not normal where what most of us are used to, where the negative side of the battery pack or the power supply or whatever is tied to the chassis and is used as common ground. This is not the case. Common ground on here is plus 12 volts. The actual supply line is the negative terminal of the battery, so call that 0 volts. It's odd, but there's nothing about it that's typically it's not mysterious. The circuitry works exactly the same way. The only thing is the polarity of the transistors, because they're PNPs, is different than what is now typical. And the polarity of the capacitors is backwards from what you might think. So if you're working on one of these, you've got to be mindful of that. You say, oh, this cap goes to ground. Okay, that's ground. And you put the minus side of the cap on the ground side? Nope, it's not going to work. Smoke. It's pretty obvious here. I don't know if you can see this. The positive side of this cap is here, and it goes directly to the chassis. In fact, you probably can see that that's red. Also indicates the positive side of that cap, which goes to chassis. So they're positive ground throughout. PNP transistors throughout. Be mindful of that. Don't let it fool you. If you look at the drawings, you know, it's going to look just like everything else, except the polarity is backwards. Ground is positive and B plus is negative. Just a note. If you hook one of these, this model up backwards, it probably wouldn't hurt the transistors. It's possible. I'm not suggesting anyone ever do that. But all of the transistors would be in reverse bias, and at 12 volts they're probably just fine with that. The problem would be some of these electrolytics, particularly this one. This big one's right across the supply, so with a modern capacitor here and you hook the battery or power supply up backwards, it's going to look like a real low impedance, almost a short. And it's either going to pop your supply or pop the capacitor, so don't do that. Capacitors excluded. I don't believe that, because of the way the circuit's laid out, and which is typical of these, that if you hooked it up backwards momentarily, that it would zorch it. There's evidence of this as well. Transistor radios, the little pocket radios that use a 9-volt battery. How many times have people, when they're replacing the battery, accidentally, they have the thing turned on and don't know it, and they accidentally touch the terminals backwards? Does it destroy the radio? Probably not, otherwise they would have made sure that that was not possible. You know, it just doesn't snap on, and you're touching the terminals and it's putting 9 volts into the radio backwards, but it's not likely to do much harm if not sustained. I mean, some of those little pocket radios did have an electrolytic capacitor right across the battery to help tend to extend the usefulness of the battery in the radio. You know, the battery dies, the impedance of it goes up. Well, they put a cap across there inside the radio, and it gives it a little less, it lowers the impedance a bit. Less sensitive to AC disturbances and so forth. So that would actually seem to extend the life of the battery, at least for the instrument that it's being used in. Is why that's there. Also, with the external DC supply, this would also help to filter out any ripple current. Point is, positive ground on these guys. Don't forget it, and keep an eye out for that when you're, looking through the drawings. It was pretty easy to spot here. It was one of the first things I noticed, but they're not always that obvious. So keep an eye out for that. As I said, I'm prepared now. I'm going to go ahead and, do some recapping. That's going to take some time. So, and I'm not boring you with how I get them in there, but I will get them in there and give it a try. See what happens.